we're going to start looking at combining functions using function notation. This is very similar to evaluating functions with function notation, so you should see the similarities. We know from last time that f of some value equals an expression is simply asking you to evaluate the expression for whatever the value is. In this example, f of 4 equals 3x plus 2. All we need to do is replace the x with 4. So f of 4 equals 3x plus 2 becomes f of 4 equals 3 times 4 plus 2. Or in this case, 12 plus 2, which is 14. This is simply expressing the value to the expression relationship. That f of 4 is simply a replacement, taking 4 and replacing the variable x. But those values can be anything. While we're used to them being numbers, such as 4, 5, 17, they can also be other variables. For example, you might see that f of a plus b, or for example, g of d plus e. These are simply variables instead of numbers that we're evaluating. The primary one that we're going to be looking at tonight is evaluating functions within functions. In this case, f of g of x. You'll recall from the last section that g of x is simply a generic term for another function. So, in this case, we're evaluating f of g of x. The value for this is g of x. What this means is that we have some function f of x equals an expression, and all we need to do is replace the variable in the expression with whatever the value of g of x is. And in most of these cases, our value is going to become another expression. Take, for example, this example. We're given the two functions at the top. F of x equals 3x plus 2, and g of x equals x plus 5. And we're asked to find f of g of x. This is the same thing as being given f of x equals 3x plus 2, and being told to evaluate this function for when x is equal to x plus 5. We're simply replacing the x in the expression with the new expression x plus 5. So in this case, our new function would be f of x equals 3 times x plus 5 plus 2. Let's look at some other examples. Here, we're given two new functions, f of x equals 3x and g of x equals 12 plus x. From the previous example, we'll assume that we're looking for f of g of x. In order to find this, we need to take the value for g of x, 12 plus x, and replace it for the x in 3x. So, as we build this expression, we start with f of x, 3, and we'll replace the x with the value for g of x, in this case, 12 plus x. We can continue to simplify this by following the distributive method. 3 times 12 gives us 36. 3 times x gives us a positive 3x. So the total value for f of g of x is 36 plus 3x. This can then be extended to values within the function g of x. Let's look at another example. Here's our next example. In this case, we're going to work with the same two expressions, f of x equals 3x and g of x equals 12 plus x. But now, our function we're being asked for, instead of being f of g of x, is f of g of 3. What we're looking for now is to insert the value of g of 3 into the function of f. In order to do this, we'll look at two different methods. The first method is the two-step method. To do the two-step method, we'll start by evaluating the innermost value, in this case, g of 3. G of 3 is equal to 12 plus x. We're replacing our value for x with 3, so our expression becomes 12 plus 3, or 15. Now we need to move on and evaluate the f function. We know that the value of g of 3 is 15. So we need to take this value and place it into our f function. F of 15 is equal to 3 times x. So f of 15 is equal to 3 times 15, or 45. This is the two-step method that gives us the final result of 45. This means that f of g of 3 is 45. Let's examine the second method. The second method involves building a single equation to solve the problem. In this case, f of g of 3, we're inserting the value 12 plus x into the function f of x, replacing the x value. We'll then evaluate it for the number 3. So, f of g of 3 can be rewritten as 3 times our value of g, which is 12 plus x. We then know that we're replacing the x with the value of 3 from our original problem. In this case, we end up with 3 times 15, or 45 again. So our total answer to f of g of 3 is once again 45. Let's take a look at one more example. In this example, our value for f of x is x squared plus 3, and our value for g of x is x minus 2. And we're being asked to evaluate f of g of 5. Let's look at the first method. We'll first evaluate g of 5. So g of 5 must be equal to x minus 2, because just like in the previous examples, our letter g tells us which equation we're working with. So it's equal to 5 minus 2, or 3. Next, we'll take this value, 3, and plug it into f. So, what we do now is take f of 3, which is equal to x squared plus 3. We replace the x with the value 3, leave the square, and add another 3. 3 squared is 9, plus 3, which means our final answer is 12. So in this case, f of g of 5 is equal to 12. Let's take a look at the other method. Same equations, f of x equals x squared plus 3, and g of x equals x minus 2. And we're still being asked to evaluate f of g of 5. But in this case, we'll use the second method, where we're combining the equations into a single equation. So we'll start with our f value. Since our first value in f is an x, we need to immediately replace that x with our value for g of x, in this case, x minus 2. So we start with x minus 2. this value is still squared from our original f of x equation, and we're still adding 3. Our next step is to evaluate the function for the value 5, which is here in the original expression. So, we'll begin by inserting 5 for x, and again, it's still squared and adding 3. 5 minus 2 gives us 3 squared plus 3, which becomes 9 plus 3, which becomes 12. So in the end, once again, f of g of 5 is equal to 12. As always, you can use one method and check it with the other. So long as both equations come out the same, you know you've done things correctly. Now let's look at a much more extreme problem. In this case, we're given 3 different functions. F of x equals 3x, g of x equals x plus 1, and h of x equals x divided by 6. And we're asked to find f of g of h of 12. In this case, we'll go with the first method and evaluate each individually. To start off with, we'll find h of 12. Our h expression is x divided by 6. We replace the x with 12, divide by 6, and we now know that h of 12 equals 2. We'll then take this value for h of 12 and plug it into g. So, we evaluate g of 2. It must be equal to x plus 1. We replace the x with 2 to get 2 plus 1, which is 3. We'll then take this value for g and plug it into f. So f of 3 equals 3x, or in this case, 3 times 3, or 9. In this case, the final value for f of g of h of 12 is equal to 9. We've simply broken down the problem and made sure to move in an organized pattern from the innermost to the next innermost to the next innermost layer. You're always going to start from the most inside set of parentheses. Now, we'll look at the same problem using the second method. So once again, f of x is 3x, g of x is x plus 1, and h of x equals x divided by 6. And we're asked to evaluate f of g of h of 12. In order to do this, we're going to start by building from the outside. In this case, we'll start with f of x. So, that's equal to 3 times x. Now, since we've reached a variable, we need to replace that variable, this x, with the function for g of x, which is located here. So 3 times, as we begin to enter our g of x equation, we notice that it also starts with an x. At this point, we need to replace this x and x plus 1 with the value for h. So we'll replace the x and x plus 1 with x divided by 6. Moving back, we can see that we still need to add the 1 to g of x. And if we come back to our original f of x, we see that we're done. Now we simply need to evaluate this new expression for the value 12. 3 times 12 divided by 6 plus 1 becomes 3 times 2 plus 1, which is 3 times 3, which is equal to 9. This is the same answer that we got right here. So we know that we've done it correctly. This is as complicated as this type of function notation will get for us in Algebra 1. So hopefully this has helped you get a grasp on how we use function notation to combine entire functions instead of just numbers.